Hello, we'll just wait a few minutes for a few more people to join and then we'll kick off. Okay, we're starting to get some people rolling in, so I think we'll start now. Okay, so good morning, good afternoon, depending where you're joining us from. Welcome to Kafka Confidential Data Encryption Simplified. A few house rules on the tech. We are recording this for later playbacks, so if you don't consent to that, please leave now. But hopefully you want to stay. We've got some React tools. We're going to have some polls going throughout the session, as well as some Q&A at the end. So please interact, as well as in the chat. We've got a few people sitting along with us today to talk to you as we go through everything. So firstly, let me introduce myself. Hi, I'm Stuart, here on the product management team at Conduktor, and Christoph's here with me as well. Do you want to introduce yourself quickly, Christoph?
Yeah, so thanks a lot, Stuart. Hi, I'm Christoph, sales engineer at Conduktor.
And we're going to be speaking today and a little bit about Conduktor for those of you not familiar. So we work to equip platform teams to enforce standards, processes throughout your organization, mainly for Kafka applications, allowing you to get ownership and autonomy throughout your organization. So kicking off, why you may need to share data, encrypted data that is. So you may be dealing with local data laws that you've got to enforce, you're working with confidential or sensitive information, or perhaps it's just your IP and you want to lock things down. You're working with new customers and partners, they have expectations, or you're sharing data outside your network. But TLDR, you've basically got a requirement. Someone's asking you to do it, or you've worked out you've got to get on with it. So, quick poll. Just want to get a bit of an insight from you people turning up today. So, why are you looking to encrypt Kafka data? That should now pop up for people. Basically, are you worried about the kind of cloud provider? Have you become a new customer requirement to come in? There's some regulatory compliance you've got to meet, or something else. If other, please feel free to comment in the chat. We'd love to hear what your use case is. So while that poll is getting out of your way, wanted to go through what today you're going to get an understanding of. From working with our customers, wanted to share a few insights, as well as the decades of experience from some of my colleagues today who helped me with the presentation. We wanted to discuss why encryption's hard in practice, what the encryption landscape generally looks like, and all the problems to do with that, as well as some standard solutions to these challenges, including the in-transit versus at rest problem, how you make sure you cover all your applications and all your clusters, and how this kind of changes when you're looking to share data with third parties. As well as that, we'll have a nice demo from Christoph showing you encryption in action within Conduktor out of the box, and how we believe we're uniquely positioned to solve all the problems we're going through today, as well as a lovely crypto shredding demo. So sharing encrypted data is hard, and that's just one part of getting the tech working. It's just part of the problem. In the beginning, you may have no security, you may be doing a proof of concept, get your application up and running, you're working out what this Kafka thing is. As things develop, then you're likely going to be asked to implement encryption on the move. So as your data is moving between your application and the cluster, you'll start looking at transport layer security. You'll perhaps bring in a library to your application that helps you do this rather than rewrite it all yourself. But if you're only encrypting in transit, then essentially what happens is you're unencrypted at rest. This may be okay for some people, but most of the customers we've been speaking to, this is just a given. Setting up TLS between different points, it just has to be done. But as it flows through from the application, you've got your payload, it gets encrypted on the move, and then as soon as it finishes moving, it's going to drop out. It's going to be plain for anyone to see at the end of the pipe. Where this gets interesting is when the end of the pipe is the broker. So unencrypted data is going to end up hitting the Kafka cluster. Because it's unencrypted before it gets there, it falls out, it's plain to see, and at this point, you're not really hitting true end-to-end encryption. Your vendors typically advise people to encrypt before the cluster. You can read this on their websites. They want you to do it because they know this is happening, because anyone who can access the JVM will be able to see all the data while it's waiting to be encrypted by the broker using their encryption service. And this might not be sufficient for your customer requirements. So just relying on TLS at the end of the day may not be enough. And there could be quite a lot of data here. Admittedly, it might not be there for very long, but you could up typically be 18 gigabytes. It could be much more depending how large your brokers are. So what's the answer? It's basically encrypting before it hits the cluster, as I alluded to. At this point, as soon as the data falls out of the transport layer security, then it's going to be encrypted, and you don't need to worry about this. Cloud provider is working with your encrypted data, and you're holding the keys. Before moving on, just wanted to cover what are the basic parts of encryption that we'll be dealing with. So you're generally working with a message that you want to send. You're going to get a key from somewhere, and you're going to use that key combined with the rest of your encryption service to end up encrypting that data, and likewise the same components on the reverse. Why I've got this slide up is because we're going to talk about key management solutions. So getting that key wouldn't be good practice just to bring it in, but actually working with a certain external service that allows you to rotate the keys and bring them in and fetch them and not manage yourself. But the important point here is you have to build that connection between your application and the KMS. So general application structure that we're looking at here, you're going to connect to your Kafka cluster, but you're also going to build a connection to the KMS. And then you're going to bring in, perhaps when you're starting off nice and early, you're going to be working with the library, bringing in an external library into your application. You probably don't want to rewrite this all yourself. So bring in an external library to work with the encryption. But the problem with this, as you start to scale, is this is going to vary client to client. Depending, you're usually going to give the freedom of which language to use to the application team that's looking to solve the problem. You're not going to want to constrain them to which language you want them to use for consistency of your encryption library. So depending on the different clients, you could end up with a different library in each one. And even then, if they're using similar ones, they may end up with different versions of this library. And assuming you don't have one KMS, you've then got to build that additional connection to the next KMS, unless all your secrets are stored just within one. So time for another poll. We've got one here asking about your KMS. So have you managed to consolidate secret management with just one KMS today? Are you looking to do that? Is something you're struggling with? Is it something you're looking to do? Or you're not really bothered and you're just going to stay with what you've got? So while you answer the poll, I will continue. So talked about the different types of client, and we talked about you may have different KMSs going on, but in reality, these are not just going to be your consumers and your producers. You're going to have the same problem on the other side, and worse. And assuming you've only got one cluster, then you may end up with this many connections, but in practice, a lot of our customers end up having multiple clusters, and you've got to cover all these applications and all these clusters. And as the mess grows, you're going to end up with many, many connections to try and get consistency and alignment across. And that's just within your organization. So what we've seen customers' typical setup is when they're looking to share data externally, they've got their main setup with their main cluster for topic A. They've had to set up a replication service of some kind, such as Mirror Maker, create a demilitarized zone, like a neutral space that's outside the core security of your internal network that you're allowing partners in, working with other teams to make this happen. But you've got to replicate that topic across, and you've got to run another cluster. So you're replicating the cluster to replicate the topics, but you're going to be replicating all these problems that I've just gone through in the previous slides. And that's just the tech. I'm not going to get into this today, but you've also, assuming you get all the tech working, you're still going to be looking at all the people problems, all the process problems. You're going to be looking at access requests, how you make sure credentials are secure and hitting the requirements of all your internal teams, resource creation, making sure you don't become bottlenecks, as well as permissions. We do offer solutions to these as well, but I'm not going to get into those today. So TLDR, you're basically doomed to implement and maintain a growing web of secrets, interfaces, and dependencies. This doesn't sound great. One last poll. We want to understand a bit more about the encryption you're looking to do. Can you do that on just the message level, or are you interested in doing this on the field level? We've definitely heard from both across a lot of our customers. So just wanted to get you thinking about that as well as how you're doing that today. So we've talked about this mess and all these issues to do with. That's all great, but can you talk to me a bit more about the solution you're probably thinking? So I want to go through the typical types of solution. One that we talked about earlier was implementing the encryption through the library that you're embedding in your applications. So the pros here, it's speedier, it's easier to set up at first. It's probably where you're going to start. And it can be suitable if Kafka is just one of the data sources for this application. However, as you start to scale, you're going to hit there's a lot of drawbacks to going with this approach. Different implementations per client, as I alluded to. Difficult to maintain and kind of align these across the producers, the consumers. You may not know who all your consumers are when making changes, which may trigger breaking changes. It can be slow to update. So if you've got vulnerabilities in that library, you're going to have to make that change in, say, patching the library across all those applications. And that same change is going to be required in each application that's using that library. And when you're making that change, it's likely you're going to have to restart or redeploy the application. So this is the first pattern, seeing it in the applications. The second kind of solution scenario we've seen is like my Kafka vendor does it for me. They're already encrypting. I've already got TLS set up. I've got encryption. But this is just the broker and transport layer security I talked about in the first few slides. So the pros of this, it's pretty simple. You know the encryption is between the applications and talking to each other. It's pretty simple overall. You don't need to worry about keys, rotation, connections to KMS, compatibility. But the huge drawback here, of course, is you've got unencrypted data at rest. This is going to fail certain data privacy requirements depending on who you're working with. The third, as I was talking about earlier, so it's going to fall out the pipe. It's going to be visible in plain. And so we need to end up encrypting that to meet most of those requirements. The third type of solution I wanted to talk about is middleware. This is what we propose as well. The pros of this is it's pretty simple. Where is doing the encryption? It's in one application. It's language agnostic. If you're working with a Kafka proxy, it's all speaking Kafka anyway. So you don't need to worry about different compatibility going on. It reduces those KMS connections because you only need to connect the proxy in the middle, that one application, to the KMS. Much simpler to scale and maintain. And it's aligned everywhere because the consumers and the producers don't need to worry about security compatibility because it's taking place in the middle before it hits the cluster. And it's quick to update. You only need to update it in one place rather than in many different places. And if you're likely to deploy this in a cluster configuration rather than just a singular instance. Therefore, you can do rolling changes leading to no downtime when you want to quickly patch application security. Of course, there are drawbacks to this as well. Excuse me. It's an additional architecture piece you've got to maintain. So you're going to have to configure it, you're going to have to deploy it, you're going to have to maintain it. And there's pros and cons of just using one algorithm that's going to be spread across the entire setup. So we mentioned sharing data with partners. So how do we kind of do that? The replication stack from earlier, and what we've done from working with our partners using the middleware, it's getting rid of the replication. So in the demilitarized zone, instead of deploying another cluster and more topics, we deploy the proxy. And this proxy is what interfaces out to your partners, and you totally control what they're seeing, what they're getting access to in there. You choose which topics you want to bring across to the proxy. You can bring across all of them if you wish. And you're not actually doing replication here. It's just a version that's available on the proxy. It handles it all for you. It looks like Kafka, speaks like Kafka. And this has allowed several of our customers to turn off clusters and drastically reduce their bill with other clients and simplify the whole setup overall. So what does this look like in practice? I'm going to hand over to Christoph, who's going to show you just a quick demo of what this looks like and how you can get started pretty much out the box from our website.
Okay, thanks a lot, Stuart. Yeah, allow me to share my screen quickly. So. Good. And basically now what we have here is we have basically our Kafka cluster, which you're going to see here. Now, basically a view, so to say, using Conduktor Console or UI. And here we're actually looking at the Kafka cluster, which has one topic. And here on the other hand, we have our middleware proxy, the Conduktor gateway, which gives you up to now exactly the same view, right? So we also see the topic here. And now the idea is that we want to deploy encryption here, using a concept which we call interceptors, so that all messages which we are going to produce through the interceptor, through the gateway, are going to be fully encrypted or payload encrypted, and are going to then show up here in the Kafka cluster to be encrypted, so to say, with encrypted fields. So it's important. Back in Kafka, this is where your data should be stored, and that's also the only real data storage. And this one here just gives you a view to which your clients connect. And we're using the console to look at both, so to say, at the same time. Okay, so let's have a look here. Gateway interceptors, deploy one. We are let me make the window a little bit bigger. Let's scroll down here and say, I want to have field level encryption. I think I already grabbed the config for that one, so let me paste it in, and then we can dissect it a little bit how it's going to look like. So now we can I might have seen this before. Besides encryption, we have also other plugins here, but right now we focus on this one. Let's have a look. Config, we're just going to encrypt one topic. You could specify records here, and then we want to store the keys, the encryption keys, so to say, in a KMS. And for that one, we are going to use a HashiCorp Vault instance, which is also running locally here on my machine. So it's very important that we use the KMS to store the keys. Now, the design goal of the gateway was we store nothing, so to say. Basically, we don't own any of your data, which also makes the whole encryption process reversible in this sense. Okay, now here in this message, also in this case, I only want to encrypt two fields. The structure of the message should be the same. So two fields should be encrypted, namely name and address. And for each of them, I'm specifying a key in Vault, which is going to reference the record ID, so like a unique ID for the business object, which is going to be stored. So why I do that will be transparent in a minute. Okay, deploy the interceptor. That seemed to have worked. And head back to our topic. Let me also head back to this topic users, and make sure we consume. Go here and now use the UI to produce some messages. Now, it's important, I'm using the UI to produce, but you could use any Kafka client. So nothing's really happening in the UI encryption-wise. That's all happening on the gateway. Let's write the first message here, Stuart. So it has been written, and see what actually appears in the Kafka cluster. So inside the Kafka cluster, we see the ID 1. We didn't say we want to encrypt this one, but both name and address have been encrypted. Let's modify the message a little bit. Write a couple more. So let's add John Louis here, produce him, and finally let's add Christoph and produce him. Right. So produce, And while we look at this one here, let's see how the messages appear inside Kafka. And basically the sensitive data, name and address of all of them have been encrypted. Now, what's the client view? What does clients actually see? For that one, basically we go here and we see the clear text. No? So basically for a client, now symbolized by us looking at console, everything is just, not completely transparent to encryption. Just see the data without having to modify the clients in any way. Now maybe you're asking yourself, why did I add the ID to the key, so to say? This gives us a nice additional use case, namely using crypto shredding, basically being able to remove John Lewis data from the very middle here of the Kafka topic. Now that's something which might be bothering us, right? So data is in Kafka, we can't get rid of it in case we have GDPR requirements, right, to be forgotten. And how we can do it, of course, we can't change the Kafka implementation here. No, that might be from the cloud provider, but we can make sure that the data is no longer accessible. And to do that, I head over to HashiCorp Vault now and look at the keys which have been created. So we have choose one encryption key for each client, no, and here John Lewis or each user. Now what we can quickly do here is I can go to details, edit encryption key, allow me to delete it, update the encryption key, add it again, and now delete this encryption key for user ID number 2. So let's do that. Yes, I know what I'm doing. And now let's head back here to console and consume the messages again. What I'm seeing is, of course, I can't change the structure of the topic, so to say, but I make sure that nobody now can decrypt the messages here. So basically John Lewis on one is still there, no, the message is still there, but I have no way to access his data. So apparently he has been forgotten. Good. That was all I want to show you in this very quick demo, but of course we're happy to take questions. But first, back to Stu.
Thanks, Christoph. Yeah, I'll just wrap up before some questions here. So resharing. Okay, so yeah, just to finish off, everything you've seen today, we'd be happy to talk more. If you just go to our website, there's a simple form to fill out and we'll get back in touch. As well as everything you've seen, you can have a go yourself completely for free. Go to our homepage, there's a curl command there to download a Compose stack, Docker Compose, and run that off your machine, and you'll be able to do everything you've seen today. So thanks very much for your time, and open to any questions in the chat. Just have a look. Got one question there on why the messages appeared in the demo unencrypted on the topic. So that was because one of the screens, we were running it through the middleware, and the middleware had the decryption available, so it could decrypt what was going on the topic. Which KMS are supported? So at the moment, we're supporting all the KMS that we've been working with customers for. This hasn't been an issue. However, if you happen to be working with one that we haven't quite built a connection for, then that's something we can easily do, but we haven't hit that yet. Regarding billing for encryption, it's part of one of the data security package product that we offer. It's not done on usage base, so it's kind of flat fee, and that's dependent on a few different factors, which I'll leave to the sales team, and I don't want to try and answer that one for you. But unlike some of our competitors, which might scale on your usage, you can encrypt as much or as many different applications as you need to. More questions? Is encryption using AWS KMS available? Yes, that's definitely what we've been working with some of our customers at the moment. So yes. Performance and resilience. Do you mind taking that one, Christoph?
Yeah, so for the resilience, basically what you can do is you can deploy multiple instances of the gateway. So if one faults over, no traffic will automatically be routed to the other one. And this is actually based on the magic of the Kafka protocol. No? So your clients have to be configured using retries, enough retries, but then it should work without issues. For performance, of course, that has different aspects, right? Throughput, latency. Latency is a little bit difficult to evaluate because, of course, it depends on how quick is the interaction with your KMS. For the raw network latency, we typically see sub-milliseconds added. And then, of course, it depends how many fields you interact, how quick is the KMS. So we have one test here with an in-memory KMS, so where we can basically get rid of the network traffic, and there we really have or about millisecond latency for a single message. Throughput, again, depends a lot on how big are your individual records. So typically on a small use case like that, we are getting about 15 megabyte, let's say on my laptop, per second on a partition or with a single gateway. So I would say it's pretty good. And what we also typically see is that you might not want to, it's more for, let's say, enterprise data, end-to-end encryption, not so much maybe for log streams or other things. Best thing to evaluate this one is to do a POC with us, or as Stu already said, download the Getting Started guide and try to play around with it yourself.
Great. And we got a question about decryption. So decryption is as simple as what Christoph showed you for setting up the encryption there. We add the decryption plugin where appropriate, and then as the data flows back through, if you're viewing it on the authorized side of the gateway, our middleware product, then it does the decryption for you. If you're connected directly to the cluster, then the data is still encrypted. So you have to be running through the authorized middleware, which allows you to get that data at rest.
Correct. And I cheated a little bit, I must say, in the demo. So I pre-set up the decryption plugin. So if I wouldn't have set this one up, actually the view here in the gateway, with the messages here, would be exactly the same as the view here on the raw data topic. So basically one plugin is responsible for encrypting, stored encrypted on Kafka, because that's the only thing Kafka knows. It only sees the encrypted data, or field level encrypted data, and then decrypted as we read back through the gateway.
And got a question there from Timothy. So data security package, if you go to our the homepage on our website, Conduktor.io, and at the top bar there's products, and then data security is where I'd recommend having a read. And why isn't it built in to the free usage pattern or the default usage pattern? Some customers are more interested in different parts of our product, such as governance, where we can protect your cluster from, say, bad configs and bad setup, such as creating topics with 1,000 partitions, and those kind of use cases to do with self-serve as well. They're not so interested in the encryption side, so we kind of split it up like that. It's based off what we've seen from some of our customers, so that's the reason it's split up today. And okay, so I think we're at time, and I think I've captured all the questions. If I haven't answered any of the questions or I've missed those in the chat, then feel free to either reach us on the website or LinkedIn, etc. But yeah, I think that was it for today. So thank you very much. It's been great being able to present to you. Yeah, check out the website for later. And yeah, thank you.
Thank you.
Right.